My senior project presentation is entitled A Glimpse into Medicine and Biomedical Engineering Through the Lens of Cardiac Defibrillation. So, I spent the 3 weeks of my senior project interning at a company called Physio Control. I job shadowed my uncle, Tom McKay, who is a systems engineer and has a background in electrical engineering. He's been there for almost 20 years, so it was really good to work with him. So Physio Control is a medical device company. They make products that deal with heart disease in the United States. They're like a company called Medtronic, who actually bought them. And Medtronic is a little more well known. So I'm going to talk a little about heart disease in the United States. So every year there are about 2,400,000 deaths in the United States, 600,000 of which are related to heart disease. And the biggest symptom that causes death actually is a condition called sudden cardiac arrest. So what sudden cardiac arrest is when there's a malfunction of the electrical system of the heart, which is a sudden loss of heart function, and that causes a lack of circulation throughout the body. And a little misconception is sudden cardiac arrest is not a heart attack. A heart attack is myocardial infarction, and that's when there's a blockage of oxygenated blood to the heart, and that causes a part of the heart to die, and thus you have a heart attack. So common arrhythmias, which is when the heart isn't beating normally, is ventricular fibrillation or ventricular tachycardia. The one I focused on is fibrillation, and that is as follows. So if you look at this diagram, the top picture is a normal heart, and the bottom is when it's ventricularly fibrillating. There's electrical signals that go through the heart, and when the signals get messed up, the heart begins to quiver rather than beating normally. And so you can see this is the echocardiogram. The bottom part of the diagram is normally it's on the beat, whereas the top picture is very irregular. And so the biggest concern is a lack of circulation, predominantly to the brain. Here's a picture of the arteries to the brain, and when blood isn't circulated properly and there's not enough oxygen, you get a condition called cerebral hypoxia. And that is a condition when the brain doesn't have enough oxygen, and after 5 to 7 minutes, brain tissue and cells begin to die and begin to undergo irreparable damage, and eventually death if not treated properly. So, I can come back to this animation, we have time later. Basically, the ventricles are your heart's lower chambers, these two, and when they quiver and don't beat properly, it's a pretty big issue. So what Physio Control does is they make devices called defibrillators and devices to solve some of these problems. And so defibrillation technology, defibrillators aren't too complex. They're also known as, shock boxes. It has a capacitor to charge a shock. It has electrodes that you attach to the patient. It normally has hardware with software loaded onto it to do the proper commands and to analyze the patient. So automated external defibrillators, this is a device that you're probably most familiar with. It's also known as an AED. And so this is the LifePak CR Plus. This is a device that is one of the newer of its line, and it's used in a variety of different settings. We have one at Overlake, we have one in the new gym, as well as down at the lower fields in the shed. This is the LifePak 1000. It's a little more expensive because it has a screen, but it is one of the newer lines. It allows you to see the patient's echocardiogram on the screen and get results from there. This is LifePak Express. This is designed for people who have some training in it. It skips some of the voice prompts, but it's better if you're more familiar with the device. CPR devices, Physio also makes these devices. I'm not going to spend as much time, but I thought I'd give them their little cameo. Lucas 2 chest compression system. This does CPR for you. You slide the patient into it, and it'll compress it to an appropriate depth and get blood circulating. This is the true CPR coaching device. You place this under the patient, and you put the handle above the patient, and due to magnetic propulsion, you can tell how far you need to decompress, because oftentimes people don't do it correctly. I'm going to spend a little bit of time. Monitors and defibrillators. This LifePak 15 is used in hospital and paramedic settings. If you look at the difference between the two devices that I've shown, the LifePak 15 is much more durable. It also has a lot of cables on the left to attach to monitor CO2 and SpO2 and a bunch of other things you need to monitor. This is the LifePak 20E. Again, it's a similar function. And so I spent a little bit of time learning about implantable defibrillators, and I spent this at the University of Washington. I went to a lecture of Dr. Gus Barty, who is a leading cardiologist, and he specializes in that field, and he's on the forefront of biomedical research. And so rather than it going outside the body, there is a device that is on your 6th rib. There's a lead that goes in through your chest to your sternum and up to your heart. It's a similar function. It shocks the heart, delivers an electric current through it. The difference is just its internal versus external. And so, I'm going to demonstrate how an AED works.
Call for help now.
So right now, there's two people. You would call
Remove all clothing from patient's chest.
You would call 911, and it's important to remove clothing from the patient's chest because you can't have any impedance.
Pull red handle to open bag.
This is where the electrodes are housed, in this little bag right here.
Look at pictures on pads. Peel one pad off glue plastic. Apply pad to bare skin, exactly as shown in the picture. Press pad firmly. Peel other pad off glue plastic. Apply pad to bare skin, exactly as shown in the picture.
So you want the electrodes to be lined
Press
up to go
pad
through the heart.
firmly. Do not touch patient. Evaluating heart rhythm. Stand by. Preparing to shock. Everyone clear. Do not touch patient. Delivering shock. Shock delivered. Provide chest compression and rescue breath.
So that's basically how it works. You want to deliver a shock through the heart. It'll analyze the heart rhythm to determine whether it's a shockable rhythm. And then you'll do CPR, which is cardiopulmonary resuscitation. And just like that, we've all learned in class. So I showed you what happens sort of externally. Now you get to see what happens, I guess, internally. So you heard a lot of things, you heard rescue instructions, and I'm not going to delve too much into it, but there's a whole field of sound engineering to make the voice prompts stand out from your surrounding environment. Oftentimes these devices are used like in a rescue helicopter, in ambulances when you're a paramedic team, or just in like a busy mall if you have like an AED or something. Process of command. So I spent my time with my uncle in systems engineering, and there's a lot of different states that the device goes through in order to carry out its function. So there's a state called pads on. There is analyzing the heart rhythm, and so I work with a lot of state diagrams, and in going through my daily meetings and daily research and everything, I would learn how the device had commands go through it. I would draw out pictures, I would take pictures and then put them into a program that helps, just archive that. And so I spent a lot of my time there. It was a little bit of busy work, but it was fun, it was good to learn, it was logic, it was good to understand how things work. The analysis of the heart rhythm, like I said, there's shockable and unshockable rhythms. And another misconception that we have, I guess, in media is that when a patient flatlines, you can just resuscitate them. And that's actually not true. A flatline is an unshockable rhythm. Normally in the hospital, they will shock to make sure the patient that's what they have to do, but it's actually unshockable. Another unshockable rhythm is you think the patient is having sudden cardiac arrest and they're not. It'll say this patient doesn't need to have a shock, so you just need to do CPR and get blood flowing throughout their body. And so lastly, an AED, a defibrillator, has shock therapy delivery. And so it'll deliver 360 joules through the heart and hopefully will stop the irregular beating and get things back to normal. It'll also give you CPR instructions, and it'll provide a metronomic talk so you can compress the chest at an appropriate rate. There's a lot of philosophies on whether CPR is effective or not effective, whether you should do rescue breaths or no rescue breaths. Dr. Barney, in fact, believes that CPR is sort of pointless. Other people believe that you don't need to do rescue breaths because if you do the ratio such as 15:2, it's not as effective because the heart only starts pumping blood effectively after 8 beats, so you'll only get about half as efficiency. And so, Physio Control, again, it's a company. It's based out of Redmond. It's not a very big company, but it's growing every day. Process development. So a lot of times there's a lot of engineers that have great ideas. And so I wanted to understand how you get an idea just from the drawing board and actually sell your product. And so there's about 5 stages. And stage 0, you talk with clinical and your customers and say, hey, what do we need for a device? What improvements do we need to make? And so that's the hospital, that's your random customers. You can talk to paramedic teams. And so they send that idea to marketing and say, can we build this device? Can we make these changes? And so the engineering team will talk to marketing, work closely with them, and understand whether it's feasible to do that. And so now there's the development stage where all the coding is written, the device shape is designed, the voice prompts are designed. There was a really interesting meeting that I attended that discussed the effectiveness of voice prompts. And the project I'm working on that I can't really tell you about is in this stage, but I can't really give much else about that. Stage 3, manufacturing and production. This is when the device is actually produced and built, mass produced as well. And then the last stage is sales and improvement. So after you have this, you need to find a bunch of clients to buy your devices, such as hospitals will buy them, schools will buy them for sports teams, paramedics need them, and a lot of other things. So some of my conclusions. I felt this experience was really worthwhile. I learned a lot about what it meant to be on an engineering team, and it also furthered my interest in science and engineering as a whole. I've always had a strong interest in medicine and engineering, and this was really great. It was really great to see the interdisciplinary action of both of them. I have a video to show about the future direction of medicine.
Dr. Erik-2013 has long been one of the world's foremost cardiologists.
Hey, great to see you.
He has now become the foremost expert in the exploding field of wireless medicine. And this explosion, he says, is about to make our healthcare better and cheaper. Watch what he does with his cell phone.
And we'll just pop this iPhone into it like that.
He shows how simply his modified iPhone produces a cardiogram for a patient.
So you just put your fingers on it, there you go. And in the second, in the first second, then it stabilizes. There it is.
The device was approved by the FDA in December and is now sold to physicians for $199. Topol's patient Ron Thompson is dealing with several significant heart issues.
You saw that on a phone. Weren't you just amazed the first time you saw that?
Yeah, absolutely. I'm just having an ECG machine hooked up to me and put all these, all shaving my chest and stick them on there and put the electrodes or whatever. But yeah, no, this is incredible.
Topol also uses a portable ultrasound, a V-scan, to image Ron's heart.
So, get a good window. Oh, there's the organ. You see these dilated.
The V-scan is made by GE, a parent company of NBC.
Can you see that? See how strong that is coming together?
He does in the office what would normally be a separate test costing $800.
There's 20 million, over 20 million echocardiograms done a year. So 20 million times $800, that's a lot of money. Probably 70, 80% we can get rid of just by having this part of the physical exam. Having your body under continuous surveillance, talking to your phone. That's the future of medicine. And so this is a heart rate.
This is his newest passion, the Visi Mobile Wrist Monitor. Topol was involved in its development. Everything a hospital intensive care unit now monitors, this does wirelessly.
So if my 90-year-old father is discharged from the hospital, it's conceivable he could go home with something like this and a doctor could monitor him remotely?
Absolutely.
His book lays out how the digital revolution will create better health care.
So this is a relatively new field, and I'm particularly interested by it. You saw how easy it was to put the device on your iPhone and get a reading of your heart. Imagine how easy it would be if you could turn this into a little defibrillator. That's just one of my interests now, and so are my personal ambitions. I'm going to Santa Clara next year. I'm going to be a bioengineering major, and I really hope to get involved with field of study related to this. I also have ambitions for med school and to be a doctor someday, and I hope to apply the skills I learned this week to my future. Thank you. Do you have any questions?
For the life pack like things, is there an idea of bug fixes, and if so, do you have any idea how long the requalification is, both at the company and FDA?
Can you say that again?
So for something like that life pack, I mean, I guess there's a concept of bugs like in any hardware or software. But I guess there's a really long qualification period with the FDA, I suspect. So if you fix a bug, what on earth do you do? I mean, do you have to go through a huge requalification, or are they really careful to just like not touch until the next generation, or what? Any idea?
So there's a lot of requirements that you have to fulfill, and the FDA is really tough, and they are pretty sticklers for their rules. A lot of times, I actually worked on a project that I took all the project requirements from the PDF document, moved to Excel. I had to read over everything and check it to make sure it was accurate. The device hasn't reached a stage where we have to check it and make sure it fulfills all the requirements, but there's a lot of software updates you can do to change voice prompts to make it actually fit correctly. It's not too hard of a process. They can send the device back. Physio actually had to recall a lot of their devices a couple of years ago, which set them back in the sense of things, but track now.
When you were working there, what was the proportion of the physicians to engineers, or did they have a combination of those backgrounds?
So it was predominantly engineering people in the section that I worked at. There's also a clinical section that is downstairs. There's not too many doctors and nurses, but there's a handful of them. There. There's a lot of marketing people there. There's a wide range of people. There's a legal section. Tracy Umberger is head of legal. That's Colton's mom. I work with her and talk to her about how patent process works.
Sudden cardiac arrest is cardiac blood clot or electrical disturbance?
Sudden cardiac arrest is electrical disturbance. Blood clots are predominantly stuff with like heart attacks and everything, but the symptoms that you need to shock are predominantly ones that you have to when there's electrical disturbance in the